Hello and welcome to this presentation that describes the DMA2D addressing mode supported by GPDMA. This is not to be confused with the ChromArt accelerator controller present in other STM32 microcontrollers known as DMA2D that also implements 2D addressing mode. This slide sums up the addressing mode supported by GPDMA. The GPDMA implements the following addressing modes: fixed addressing, typically used to access a peripheral data register; contiguously incremented addressing, typically used to access memory in ascending address order; block maximum size in 64 kilobyte due to the 16-bit field called BNDT, which stands for block number of data bytes to transfer. The channels 6 and 7 of the GPDMA1 and GPDMA2 implement additional addressing modes: repeated block mode, based on a programmable counter; programmable source and destination signed burst address offset; programmable source and destination signed block address offset. Thus, two programmable strides can be inserted between consecutive bursts and between consecutive blocks. It's to added that from a software driver point of view, the GPDMA2 channels 0 to 7 are registered as DMA channels 8 to 15. From a software driver point of view, the 2D addressing capable DMA channels are the channels 6, 7, 14, and 15. This figure highlights the repeated block mode and the stride between blocks. This is useful to transfer the contents of a peripheral data register, typically an input FIFO, to non-contiguous buffers in memory. After filling a block of n words, the DMA channel automatically adds the BDRA0 signed offset to the current address, thus jumping to the next buffer in memory. At the end of the transfer, when k blocks will have been transferred, the CXDAR register, which points to the beginning of the first buffer, can be automatically restored in order to implement circular buffers. This automatic restoration requires a link operation. In this example, bursts are placed contiguously in memory, so the burst destination address offset, the DAO field of the CXTR3 register, must be null. For performance optimization, destination transfers should be programmed as forward bursts. This figure highlights the repeated block mode with the stride between bursts and the stride between blocks. The GPDMA transfers k blocks of j bursts, each burst containing I words. The stride between blocks is useful to transfer the contents of a peripheral data register, typically an input FIFO, to non-contiguous buffers in memory. The stride between bursts is useful to interleave or de-interleave data and also to align data. Some use cases will be described in the next slide. The first use case of burst stride is 24-bit extension and packing. A source buffer contains data and control pairs. The GPDMA channels 6 to 7 are capable to extract the data field and to perform packing by storing the resulting 24-bit data back-to-back in the destination buffer. On source, the following configuration is appropriate: a burst address offset of +1 byte and a burst length of 3 bytes. No burst stride is needed on destination. Destination can be programmed as forward burst for best performances in writes. The second use case consists in de-interleaving stereo audio samples into two separate buffers, one containing the right samples, the other one the left samples. There are several possible implementations. One may be based on two GPDMA channels, one for left samples, one for right samples. Then, if the source buffer contains two N samples, the left or even samples may be read by a programmed source one-word burst with a source burst address offset of 4 and a source block size of 4n bytes. And destination can be programmed as forward burst for best performances on writes. An alternative implementation may allocate one single GPDMA channel: a source with bursts of one word and a source burst address offset of +4. A source with two blocks, i.e. BRC equals 1, one source block being 2n bytes. A destination with forward burst optimized writes, optionally with a destination block address offset. In the last use case, data is de-interleaved and packed into 3 buffers. This could be the deinterleaving of RGB pixel color components. Similarly, a single channel or 3 channels may be used. In addition to this presentation, you can refer to the other presentations on the GPDMA, DMA Overview, DMA Transfers Hardware and Software Views, Autonomous DMA and Low Power Mode, DMA Linked List, DMA Circular Buffering and Double Buffering, DMA Register File, DMA Error Reporting, and DMA Input-Output LLI Control.